CP at 127th and Adelaide.
For over 4 decades, Voyager 2 has journeyed through the cosmos, painting a stunning picture of our solar system and beyond, captivating the hearts and minds of millions. However, in a shocking turn of events, NASA has faced an unprecedented and heart-stopping crisis, losing contact with Voyager 2. The silence of Voyager 2 echoes through the cosmos, leaving us to wonder, what led to NASA's accidental loss of contact with Voyager 2? Is it a glitch in the cosmic dance, or a reminder of the challenges that come with pushing the boundaries of space exploration? Join us as we navigate the cosmos and dive headfirst into the heart-stopping story of NASA's accidental loss of contact with Voyager 2. Last month, the spacecraft, which has been exploring the universe since 1977, accidentally tilted its antenna 2 degrees away from Earth due to a wrong command. As a result, it stopped receiving and sending data. However, recently, during a routine scan of the sky, NASA successfully received a heartbeat signal from Voyager 2, giving hope that contact is partially restored. At the moment, Voyager 2 is hurtling through interstellar space, approximately 12.3 billion miles away from Earth, traveling at a mind-boggling speed of around 34,390 meters per hour between the stars. Since July 21st, the probe has been unable to receive or respond to commands from NASA's Deep Space Network, a network of large radio antennas spread across the globe. Despite this setback, the space agency remains optimistic as they manage to confirm that Voyager 2 is still operational and in good condition. To re-establish communication, NASA's antenna in Australia's capital, Canberra, has been tirelessly attempting to detect any signals from Voyager 2. Additionally, they have been sending the correct command to the probe's area, hoping to make contact. Although full communication is not yet restored, Voyager 2 is designed to reset its orientation periodically throughout the year to keep its antenna pointing at Earth. The next reset is scheduled for October 15th, and NASA anticipates that it should enable communication to resume. In the meantime, NASA expects the spacecraft, equipped with various scientific instruments, to continue on its planned trajectory through the universe. Considering the immense distance, it takes approximately 18 hours for signals from Voyager 2 to reach Earth. Nonetheless, the recent signal indicates that the probe is still actively transmitting data and operating well. But what is the significance of Voyager 1 and Voyager 2 in space exploration, and why are they considered remarkable space probes? Voyager 1 and Voyager 2, created by NASA, are remarkable space probes that hold the title of being the farthest human-made objects ever sent into space. These twin probes have amazed the world of science with their incredible discoveries. Scientists and astronomers worldwide have praised them as an ongoing source of scientific insights. However, some of the images captured by these space probes, particularly one of Jupiter's moon Io, have raised suspicions due to NASA's habit of keeping them confidential. Io is a fascinating place and the most geologically active body in our solar system. It boasts a significant number of volcanoes scattered across its surface. These volcanoes result from a process called tidal heating, where Jupiter's immense gravity stretches Io's interior, turning rock into liquid magma that eventually erupts to the surface. Due to the abundance of volcanoes, Io looks like a vast bowl of cheese or a less appetizing pizza. While it might be puzzling to find active volcanoes beyond Earth, NASA's decision to keep the photo of Io's active volcanic plume taken by Voyager 1 secret becomes understandable. Active volcanoes are rare in our solar system, as most celestial bodies lack geological activity. In the late 1970s, the Voyager spacecraft explored Io and made fascinating discoveries. It found more than 5 active eruptions during its flyby and even managed to capture one of them on film. Since then, scientists have detected and mapped over 150 active volcanoes on Io, with around 400 more theorized to exist. Among these extraterrestrial volcanoes, Loki stands out as the most impressive. Loki, while not the largest volcano in our solar system, is undoubtedly the most powerful. It boasts a groundbreaking diameter of 202 kilometers. However, what truly mesmerizes scientists and astronomers is the molten underground lava lake that feeds Loki. enabling it to shoot lava hundreds of miles into space with incredible force. This extraordinary power captured the attention of the entire scientific community upon its discovery and continues to be a subject of intense interest. Now, you might wonder why Loki's eruptions are closely monitored. While eruptions are indeed a factor, there's more to it. Loki has a peculiar habit of sticking to a schedule, as observed by astronomers. Speculations suggest that it might erupt again soon, and this time, it could be even more potent. Considering its ability to propel lava vast distances into space, a more forceful eruption could be awe-inspiring. Loki's predictability makes it particularly intriguing for researchers. The volcano's brightness in the infrared spectrum makes it easy to detect from telescopes on Earth. Scientists have studied Loki extensively over the last 2 decades and found that it brightens significantly during eruptions. In the 1990s, it erupted approximately every 540 days, but recent studies show a shorter interval of around 475 days. The ability to predict Loki's eruptions can be attributed to its size. Being so large, the basic laws of physics are likely to dominate its eruption patterns. This sets Loki apart from smaller volcanoes, where various complicating factors can make predictions more challenging. The volcano's behavior wasn't well behaved, according to Rathbun's statement in the early 2000s. They noticed a 540-day pattern in Loki's behavior, but after that, it changed and didn't show any periodic behavior until around 2013. So the volcano seemed to live up to its name. Still, scientists didn't give up and conducted a new study led by Catherine, a planetary scientist, and her team. They examined 3 decades of observations on Loki's ebb and flow, hoping to find patterns that could explain its activity in relation to Io's orbit around Jupiter. Some people expected Io's volcanoes to behave in a certain way due to the orbital trends, which wasn't surprising, as Catherine pointed out. However, there were others who thought that the volcanoes might be so complicated that they wouldn't necessarily follow these orbital trends. To understand Io's orbit impacts, they first had to determine its details, which takes about 1.77 Earth days. Unfortunately, this was too fast to observe thoroughly using Earth-based telescopes, since they can only see Io when it's in their line of sight. Apart from the fast orbit, there are much slower cycles, spanning hundreds of days, embedded within Io's orbit. These cycles, influenced by other moons pulling at Io, could also affect the moon's tidal heating. It has been a fascinating quest to find patterns in volcanic activity driven by tidal heating. The idea is that tidal forces should create volcanism following specific patterns or paths. This means there should be volcanoes erupting in certain locations on the surface, while other areas remain inactive. Additionally, these volcanic events might show distinct patterns over time. To study the volcano Loki on Jupiter's moon, the researchers gathered all available observations spanning 3 decades. Although much of the data was sporadic before 2013, there was a concerted effort by scientists to maximize observations since then. Consequently, they now have the most detailed data on Loki's volcanic activity, which is truly impressive. According to Julie Rathbun, who studies Loki but was not involved in the new research, getting comprehensive data from the ground is challenging. The researchers focused on studying Io's orbit around Jupiter, which was relatively easier to examine. However, this might not be the first factor that volcanologists typically consider when studying volcanoes on other planets or moons that are less influenced by tidal heating. Unlike terrestrial geology, where tidal effects are not significant drivers, studying planets and moons requires considering tides and periodicity as essential factors to measure. The researchers drew inspiration from similar cyclic behavior observed on one of Saturn's moons, Enceladus, where plumes brighten and dim in sync with the moon's orbit. They found 2 cycles in Loki's volcanic activity, lasting 454 days and 480 days, possibly influenced by tidal heating. These time frames align closely with Io's orbital adjustments caused by its neighboring celestial bodies. This suggests that these cycles are more plausible explanations for the volcano's behavior than direct ties to its orbital period of 1.77 days, which is too rapid for the volcano to respond. Understanding how Loki works isn't just about comprehending what occurs on a massive planet's weirdo moon. Earth and Io are the only worlds in our solar system where it's easy to study volcanoes. However, scientists believe that comprehending this phenomenon is vitally important in the bigger picture of planetary science in our solar system and beyond. Such global-scale, tidally driven geophysics is unique to alien worlds like Loki, where processes not observable on Earth can be studied. By doing so, we can broaden our understanding of geophysics, making it less Earth-centric and more encompassing. Declaring this discovery, her colleagues aim to continue monitoring Loki regularly to understand how Io's orbital cycles govern its activity. They have calculated when the volcano might rumble based on each timeline, and within a few years, they hope to gather sufficient data to gain a better understanding of Loki's dynamics. This process promises excitement, especially when approaching the predicted times for the volcano's brightening, as they can observe and analyze the changes in images. Interestingly, this magnificent discovery would not have been possible without Voyager 1 and its twin probe, Voyager 2. Despite the name, Voyager 2 was launched before Voyager 1, taking off from Cape Canaveral Space Launch Complex 41 on August 20, 1977, aboard a Titan III Centaur. Voyager 1 followed suit on September 5 of the same year, with a primary focus on Jupiter and Saturn. On the other hand, Voyager 2 not only visited these giant planets, but also ventured further to explore Uranus and Neptune. However, the pair didn't stop there. Voyager 1 officially entered the vast expanse of stellar space on August 25, 2012, while Voyager 2 accomplished this feat on November 5, 2018. These two probes continued their remarkable journey through the cosmos. They possessed enough power and fuel to keep their scientific instruments operational until at least 2025, as per NASA's estimations. These space probes were about to demonstrate their value in impressive ways. Voyager 1 made a significant discovery, spotting a volcano on Jupiter's moon. Voyager 2, on the other hand, outdid itself by capturing a truly awe-inspiring image of Neptune's rings on August 26, 1989. This image was particularly remarkable since astronomers had previously suspected that the outermost major planet, Neptune, possessed rings. It was only in 1984 that astronomers recorded peculiar light fluctuations before and after Neptune passed in front of a distant star. These fluctuations were caused by the ring material blocking the star's light. However, it was NASA's Voyager 2 spacecraft that provided concrete photographic evidence for the existence of Neptune's rings on August 22, 1989. During this time, the spacecraft was a few days away from its closest encounter with Neptune. As Neptune grew larger in the spacecraft's cameras, it managed to capture images of a faint yet continuous ring system encircling the planet. These images served as confirmation of long-standing suspicions held by astronomers. Even today, Voyager 2 remains the sole earthly spacecraft to have come into contact with Neptune. Subsequent to Voyager's flyby in 1989, the Hubble Space Telescope and telescopes based on Earth have imaged Neptune's two brightest rings. Astronomers assigned names to these Neptunian rings, naming them Adams and Leverrier. These names pay tribute to John Couch Adams and Urbain Le Verrier, whose individual calculations played a crucial role in pinpointing Neptune's position in the sky, ultimately leading to its discovery in 1846. According to NASA's Solar System exploration, 3 more rings were discovered later. These rings are called Gallet, Leverrier, and Lassell. Starting from the vicinity of the planet and extending outward, these main rings offer insight into Neptune's composition. Furthermore, Neptune boasts 4 prominent ring arcs, named Galatea, Variella, Semira, and Leucothea. These arcs have perplexed astronomers, as their existence seems to defy the expected laws of motion that would cause them to spread out into uniform rings over short periods. Scientists now theorize that the gravitational effects of Galatea, Neptune's moon just inside the main ring, play a role in maintaining these arcs. Similarly, 4 distinct arcs, Liberté, Égalité, Fraternité, and Courage, reside in the outermost rings. Voyager's encounter with Neptune prompted careful adjustments by the engineering team, enabling the probe to conduct a close flyby of Triton, Neptune's largest moon. The flyby revealed evidence of relatively young and geologically active surfaces, with erupting geysers expelling materials into space. This finding challenged the notion that Triton was a mere solid ball of ice, despite its bone-chilling surface temperature of -235 degrees Celsius. Voyager 2's discovery of Triton's characteristics has served to inspire humanity's further exploration of space. NASA expressed keen interest in returning to Triton for a more comprehensive study. NASA's flyby mission, codenamed Trident, might encounter abundant liquid nitrogen geysers in the southern hemisphere of its target. These findings were first uncovered during NASA's Voyager 2 mission in 1989, when it made its closest approach to Triton, capturing a fascinating mosaic of images from this frozen world. If confirmed, a future flyby in 2038 could provide further insights into the origins of this volcanism. Scientists, including geologists, are particularly curious about the formation of Triton's peculiar landforms and whether it possesses an ocean. This curiosity is a significant step in humanity's space exploration, and it adds another historical milestone to Voyager's journey. Back on January 24, 1986, Voyager 2 made a historic encounter with Uranus, the remote seventh planet of the solar system. The spacecraft passed within 81,500 kilometers of Uranus's icy blue-green cloud tops, becoming the first and only human-made craft to visit this planet during its closest approach. The weeks surrounding the encounter were filled with valuable scientific data that dramatically changed our understanding of this distant and enigmatic world. Thanks to Voyager 2's data, we learned that a day on Uranus lasts approximately 17 hours and 14 minutes. Its atmosphere resembles that of other gas giants, primarily composed of hydrogen and helium, with underlying water, ammonia, and methane ice. Before Voyager's mission, observations from Earth had already revealed that Uranus's rotation axis was tilted at a staggering 98 degrees, causing its polar axis to lie almost in the plane of its orbit. Scientists speculate that a collision with a planet-sized object in the early history of the solar system caused Uranus to tilt on its side, leading to the most intriguing seasonal patterns among all the planets. Voyager 2 also made some fascinating discoveries about Uranus. One of the most peculiar findings was about Uranus's magnetic field, which tilts 59 degrees from its axis of rotation. This creates a non-uniform magnetic field that can vary in strength by up to 10 times. Voyager 2 also found radiation belts around Uranus, similar in intensity to Saturn's, and Earth has its own radiation belts known as the Van Allen belts. When Voyager 2 explored Uranus, it not only revealed information about the planet itself, but also about its many moons. Initially, scientists discovered 10 new moons, adding to the 5 already known at that time. However, later analysis of Voyager 2's data brought the total count to 27 moons. Among these newly discovered moons, one was just 160 kilometers in diameter, with a gray, heavily cratered surface. Voyager 2 also provided detailed images of the moons that were already known, shedding light on their intriguing geology. One of the moons, named Miranda, gained the nickname Frankenstein Moon due to its strange patchwork appearance. Before Voyager 2's arrival, scientists had already spotted Uranus's rings from Earth. But during its flyby, Voyager 2 made 2 new ring discoveries, bringing the total number of known rings to 11. Nowadays, we are aware of 13 rings around Uranus, thanks to Voyager 2's invaluable contributions. After studying Uranus, Voyager 2 continued its journey and reached Neptune in August 1989, before venturing out of the solar system. Even today, Voyager 2 remains relevant as scientists continue to study its data, revealing new mysteries about Uranus's rings. In December 2018, NASA announced that Voyager 2 had entered into interstellar space. After its launch from Cape Canaveral in 1977, the spacecraft has traveled an astonishing 19.3 billion kilometers away from home. Astronomers were amazed by the recent discovery of the elusive Zeta ring in Uranus's ring system. This ring had been difficult to find for almost 20 years after Voyager 2's flyby. However, researchers were pleasantly surprised when they found a new image that showed the Zeta ring. The image was created by combining hundreds of pictures from Voyager 2's data, revealing valuable information that had been missed before. The new image, along with previous Voyager photographs, helped scientists estimate the Zeta Ring's distance from Uranus, about 37,000 kilometers above the planet, and its brightness. But the values obtained were puzzling, because observations from the Keck Observatory in Hawaii in 2007 showed different results for the Zeta Ring's location and brightness compared to the Voyager images. Over 20 years, the Zeta Ring moved away from Uranus and seemed stronger in Keck's observations than in Voyager 2's. This suggests that dust was added to the system, but the reason is still unknown. Possibilities include a space rock hitting Uranus and breaking into debris or changing seasons. Whatever happened to the Zeta Ring had a big impact, yet scientists didn't notice it. NASA plans a major mission to explore Uranus, but data won't be available for decades. The James Webb Space Telescope already captured a stunning image of similar rings around Neptune, promising future discoveries. Voyager missions significantly advanced science and astronomy, helping us better understand the universe. Discoveries like an active volcano on Jupiter's moon ignite curiosity about other hidden phenomena out there. Thanks for watching another episode of Voyager. While you are still here, make sure to click the video on your screen for more quality content.